In the last video, we had done how to expand a determinant and we solved a couple of problems, correct? Now we'll start with properties of determinants. Now properties of determinants are extremely important. The reason is, whenever you have a determinant problem, rather than just expanding the determinant, we use properties and we can get the result of the determinant. Okay, now there are few properties. We'll look into the properties in detail now. Fair enough? So let's start from property 1. So we'll start with the first one. Now the first property, what it tells you in determinant, suppose if the rows and columns interchange, then the determinant is going to be the same. In the sense, suppose say we have determinant of A, let's say A is equal to, determinant of A, you have A1, A2, A3, B1, B2, B3, C1, C2, C3. Say the determinant of this will call it as delta. Now if rows and columns interchange, basically what we are saying is, suppose if you have a transpose of this particular matrix. Okay, that's the whole point of it. Suppose if rows and columns interchange, then the new one, let's call it as A dash. A dash will become, so you are going to have A1, B1, C1, A2, B2, C2, A3, B3, C3. Let's call this as delta dash. What the first property tells you is that delta is equal to delta dash. The determinant is going to be the same. Okay. Now see here, in this video, let's talk about all the properties. In the upcoming videos, we'll look into the examples and problems where you can understand, okay, yeah, this is the property and we are going to use that. Fair enough? So this is the first property. Now again, I'll tell you, if you interchange row and column, if you interchange these two, then the value of the determinant is going to be the same. Fair enough? Let's look at the second property. The second property talks about the interchanging of row and column. In the sense, suppose say you have the second property, right? Suppose say A is the matrix. For that we are calculating the determinant. Let's call this as delta. So let's say delta value, we talk about A1, A2, A3, B1, B2, B3, C1, C2, C3. Say this is the value of delta. Suppose if you exchange the value of the row and column, in the sense, not row and column, suppose say we interchange two rows. See, A1, A2, A3 is the first row. What if A1, A2, A3 becomes the second row or the third row? We are exchanging the rows. Or A1, B1, C1 is the first column and A2, B2, C2. What if you interchange the column? Okay, now let's call this as A dash, or this becomes delta dash. Suppose say we interchange, say this is C1, C2, C3, B1, B2, B3, A1, A2, A3. Now here, what did we do? We interchanged these two, correct? We did interchanging of the row here. You can also do interchanging of the column. Okay, now what exactly happens here is that value of delta is equal to minus delta dash. The determinant changes the sign. Delta is equal to minus delta dash. We'll look into the example in the upcoming videos as to how and why this is true. Fair enough? Let's go to the third property. See, in the third property, what you have is, suppose say you have a determinant, say delta is equal to A1, A2, A3, B1, B2, B3 and C1, C2, C3. Say you have a determinant. Okay. Suppose if two rows or two columns of the determinant is the same, then the value of determinant becomes 0. Okay, in the sense, suppose if my second determinant, delta dash, let's say we have two columns to be equal. In the sense, say this is A1, A1, A3, B1, B1, B3, C1, C1, C3. Then delta dash is equal to 0. In the sense, here if you have, see this first column, see this second column, both the columns are the same, correct? That's why we can say that delta dash becomes 0. So the law or the rule is if you have two columns to be the same or two rows to be the same in a determinant, then the value of determinant becomes 0. Fair enough? Now this is a very, very useful property. Very, very useful property. The second property, interchanging of row and column, that one. And the third property. And you're going to learn more properties. Okay, these properties are extremely useful in solving problems. Now we'll look into the fourth property. See, the fourth property, what it tells you is that, suppose, say, we have a determinant delta is equal to, say, A1, A2, A3, B1, B2, B3, C1, C2, C3. So this is the value of delta. Now what if one of the rows or one of the columns has a common multiple, or say you are multiplying the value, either a common multiple or you are multiplying a value. Say you have 3, 6, 9 as the elements in first row. 3 is common and you can take the 3 outside, correct? So that means here, suppose if you have delta dash k into A1, k into A2, k into A3, there is a common factor. Next one, let it be, suppose say we'll take it as L into B1, L into B2, L into B3. Say for the next one, we'll keep it as it is, C1, C2, C3. Now in this case, from the first row you can take k common, from the second row you can take L common, isn't it? So that means my delta dash becomes k into L into the determinant value, which is delta. Okay, so what do we get here? We get delta dash is equal to k into L into delta. So when you have a common factor for one of the rows or one of the columns, then you can take the common factor outside. The whole determinant gets multiplied by that value. Okay, this is the fourth property. So this is also quite an important property because it helps a lot in solving problems. You guys will figure out how it helps in solving the problems. Okay, now these are the first 4 properties. And in the next video, you guys are going to see few more properties of determinant.